Okay, we are moving into the last concept of our Pythagorean theorem in trigonometry, which is part of simplifying radicals is the vocab word that we're going to be dealing with today. Your learning target, you can simplify radicals into, of course, the simplest radical form. Now, what does that look like? Now, I want you to remember that what an irrational number is, it's not a perfect square root, meaning the square turns into a decimal, like the square root of 37, because 37 is not a perfect square. Or the square root of 40, again, not a perfect square. You would get a decimal as an answer. You can simplify this, though, in exact form, meaning you don't simplify it to the nearest 10. You simplify it into the nearest, or the most simplest radical form. Simplifying just means breaking down as much as you can. And that's what we did when we did prime factorization. We simplified a large number into its primes. You break it down. And radical is the square root symbol. Another word for that is radical. You'll hear me call it a few different words today. I'll call it radical, I'll call it root, I'll call it square root. They're all synonyms. They all mean the same thing, just the square root of something. Like this, the square root of 40, I would call it root 40, the square root of 40. I don't ever really say radical 40. Actually, I don't really know anybody that says radical 40, but it's a radical sign that represents it. So with your warm-up questions, you had to do, what was it, the square root of 49 squared, right? There's something very, very, very important that you need to know for today's lesson. So the square root of 9 squared is really 2 root 9s. So it's really the square root of 9 times the square root of 9, which is 3 times 3, which is 9. Now I'm seeing a pattern, and now I'm going to make a hypothesis that if I square a square root, I think I'm just going to get the number that's inside the square root symbol. Let me test that hypothesis out. The square root of 16 is really root 16, same as square root, times root 16, which is 4 times 4, which is 16. Hey, look at that. That's interesting. It's the same number that's inside the square root symbol. So then I can generalize this and say the square root of x squared is going to be root x times root x, which will just be x. So any number, any square root of a number squared turns into the number itself. For example, the square root of 32 squared will be what? 32. The square root of 7 squared will be? 7. The square root of 2 squared will be? 2. According to that generalization that anytime you square a square root, it just gets rid of the square root. It's an opposite or inverse operation, and you get what's inside. Okay, huge for today. Now what we're going to do with that knowledge is connect that to simplify irrational roots or radicals. Irrational means it's not going to be a perfect square, but you need to break it down as much as you can. Some of you, if your calculator was programmed weird sometimes, you might have seen something like this come up when you figured out something. You're like, why did that come out? And you had to change your mode. This is what we're going to be doing today. This is simplest radical form. Okay? So, your target, simplify it. What we're really doing is taking any perfect square roots out, and you're going to make a root tree. Root is just like factor. You're just breaking numbers down, and you are going to be, this is the heart of today, is anytime you square a square root, you get the number inside. Watch this. The square root of 40. I want to break the square root of 40 up. Well, you can break it up any way you want. I right away think 10 and 4. Okay? But it's not 10 and 4, it's square root. So we break this out into square root of 10 and square root of 4. It's just like factor trees, just with that radical symbol in there. And the square root of 10 is root 5 times root 2. You agree with that? Mm-hmm. Now I'm done, because it's prime. Square root of 4 is root 2 times root 2. So once you get to the bottom and you're done breaking it down, you have to go back to the heart that I was talking about. And I say, can I connect anything together to make that number itself? Can I pair anything up? So notice I can combine these twos, can I? Mm-hmm. Root 2 times root 2 turns into what? 2. Root 2 times root 2, and that's this. Root 2 times root 2 is going to be 2. So this turns into 2. Can you pair anything else up? No. So then it's really prime factorization or root factorization is always multiplying. So this is going to be times the square root of what's left. I'm left with 5 times 2. Do you see where the 5 and 2 came from? I have the big square root symbol, a 5 left and a 2 left. This all means multiply. And you simplify it into 2 root 10, and that's simplest radical form. Let's try that again. So looking at the square root of 500. I break this down into the square root of 100 and the square root of 5. Do you feel like you could start that? Maybe it's that last part that's messing you up a little bit. The square root of 100 is root 10. Whoops. Let me make my square root symbol a little nicer. The square root of 10 times the square root of 10. I know to stop here, because anytime you have a pairing, it just turns into the number, right? Mm-hmm. Root 10 and root 10 would just turn to 10. You don't have to. If your eyes don't notice that yet, keep breaking it down. I would keep it like this, but I'm going to keep breaking it down. This would be root 5 times root 2, and that would also be root 5 times root 2. Once you get to that broken down where you're in the primes, I asked myself, can I connect any two? Do any two cancel each other out using this rule that if you square a square root, if there's 2 of them, it will turn into the number? Hence?
The 2 and the 2 and then the 5 and the 5.
Yep, so these 2 turn into a 2. The 5s turn into a 5. It's multiplying, because that's what all this is, times 5. And then I'm left with something. What am I left with?
5.
Root 5. So you put the square root of 5 there, because you're left with it. It can't pair up with anything. 2 times 5, 10 root 5. And that is the simplified version. And notice if your eyes, remember how I told you I would have stopped right here? It would have been the same thing. You would have been like, oh, this turns into 10. I have the square root of 5 left. Okay? But if you don't notice it, you can break it down. So let's try to do square root of 320. You try to do that one. Break it down. Okay, I gave you some time to break down that square root of 320 into its simplest radical form. That means that I take that bigger number, I break it down, and I try to take any, it's really taking perfect square roots out is really what I'm doing. So, I I don't know if there's any perfect square roots, but I know that I can definitely break this down. This would be the square root of 32 and the square root of 10. Are those the numbers I have to start with? No, we will all get to the same thing. We will all get to the same thing. It doesn't matter what you start with. This would be root 8 times root 4. Root 4 times root 2. Hey, look what my eyes noticed. 2 root 4s would turn to a 4. I'd be able to cancel this out right away, but if you don't notice that, it's okay. You could just keep going. Root 2, root 2. Square root of 10 is root 5. Root 2, hey, I almost forgot about this branch. Root 2, holy moly, root 2. I'm just checking to make sure that I didn't forget anything. I broke that down, prime, broke this down, I'm good. Now I look for that pairing, that fact, like we have up here, that I'm trying to pair things together because it will give me the number itself. So this turns into what? 2. Now I'm going to go dot because it's all times in. I can pair another 2, right? Now I'm going to go dot. Can I pair anything else? Another set of 2's. And then what am I left with?
6.
5.
Times the square root of 5. Right? And then this would be 2 times 2 is 4, times 2 is 8. 8 root 5 is the simplest radical form. Okay, so that's your learning target today. Now we got to bump it up. Sometimes you're going to have leading numbers. It's the same thing, except at the end, you just multiply the whole numbers. Like if I had a 3 right here, this would turn into 24 root 5. I would just go 3 times 8. So you still break it down. In the end, just make sure you multiply the numbers. I want to erase this. So. Okay, so this would be 12 and 4. Square root of 12, square root of 4. Watch this. Watch what I'm going to do. I'm going to break 12 into 4 and 3. And then watch this. Do you notice anything I can pair up right now? Same. I noticed the 4 and the 4. What does the 4 and the 4 turn into?
4.
No, it turns into 4 because it's root 4, which would be just 4. So this turns into 4 root 3, right? Because you have the square root of 3 left. And then you bring this 3 down. It just means times it by 3. So it's 3 times 4 root 3, which is 12 times the square root of 3. Let me make this look a little prettier. Okay, so what I did, I brought that 3 down. That just means times. You times the whole numbers, not inside the root symbol. You times the whole numbers, and then that will get you your simplified form. Let's practice a couple of them.